Welcome to The Explainer. Today we're diving right into how Chapter 11 takes the honestly pretty abstract math of volume and mass and translates it into a tangible real-world reality for kids. Teaching concepts like capacity and weight can so easily devolve into just boring memorization of formulas and units. But the source material we're unpacking today takes a completely different, highly tactile approach. It doesn't just tell, it shows. And more importantly, it asks the learner to literally feel it.
Here is our roadmap for The Explainer today. We'll start with the Everyday Math Challenge, then move into filling up, followed by the 1-liter benchmark. After that, we shift gears to lifting, and finally wrap it up with measuring with a balance. Let's jump in.
All right, Section 1, the Everyday Math Challenge. Let's see how they translate math into reality. Picture this. We're immediately presented with a lively sugarcane juice stand. And there's a really compelling proposition on the sign. It says, drink 6 glasses of juice and get your money back. It's your classic vendor's challenge, bright, colorful, and instantly recognizable if you've ever walked through a local street market. But instead of asking some dry, standard math question, the text poses a brilliant riddle right away. It asks why the character, Chintu, outright refuses to take this seemingly awesome challenge. He emphatically says, "No, I cannot drink 6 glasses." So, why not? Well, the teacher's notes kind of give away the secret here. The whole goal is to build an intuition about relative volume, but through a real-world consequence. Chintu isn't doing math on paper. He just looks at those massive glasses and knows his stomach literally cannot handle 6 of them. He knows he could only drink 6 smaller glasses. This grounds the concept of capacity right away, not in abstract milliliters, but in the physical limits of a kid's own stomach. It's honestly genius. So now that we're hooked by Chintu's dilemma, we arrive at Section 2, filling up, where we really start understanding capacity. How does the book actually teach us to visualize these differences? Look at this. By placing a single large glass side by side with a collection of much smaller vessels, the concept of relative capacity becomes instantly obvious. One big container takes up the exact same visual space as a bunch of smaller ones. You don't even need to know how to read to understand what this graphic is communicating, right? Then, it brings the human element back into the geometry. We see Nita, Monu, and Ritu holding different size glasses filled with milk. This brilliantly illustrates the whole more versus less contrast. It asks the student to actively identify who holds the most and who holds the least liquid. It's basically training the eye to estimate volume quickly, forcing them to compare a tall, wide glass with a shorter or narrower one. Next up, things get interactive. We transition the student from just observing pictures to actually estimating. How many small bowls does it take to fill a larger vessel, like a glass or a bottle? The curriculum designers are literally forcing students to make a hypothesis, a guess, and then actually test it out by pouring water. It is the scientific method, entirely disguised as water play.
Which perfectly segues into Section 3, the 1-liter benchmark, moving from guessing to standardization.
Once that basic intuition of more and less is baked in, the chapter introduces the gold standard, the 1-liter benchmark. Students look at everyday objects, bowls, jugs, and guess their capacity against this new 1-liter metric. And notice, they aren't asked to measure exactly at first. They're just asked, is it more or is it less? It's a great way to build confidence before demanding strict precision.
To really ground the standardized measurement in daily life, the text asks a highly practical question. Why does the local milkman use specific measuring cups every single day? It connects what they are learning in the classroom to the local economy right outside their window. Standardization matters because fairness in trade matters. That 1-liter mark, it isn't just math, it's trust.
Let's shift gears now. We've tackled the visual nature of capacity. Our second act explores mass. Section 4, lifting, discovering weight. The book literally turns the classroom into a laboratory here. It asks students to physically hold 3 textbooks in one hand, a pencil box in the other, and just hold them for 30 seconds. Now, 30 seconds is a surprisingly long time when you're a kid holding heavy books. That muscle fatigue, that is a profound, unforgettable lesson in mass, because you can't just see weight, you really have to feel it. Then it expands on that physical discovery with a comparison chart. Kids are asked to test and discuss the weights of their school bags, lunchboxes, and fruits. And I absolutely love the column for My Friend's Observation. It encourages peer review and cleverly acknowledges that physical sensation can be subjective, which is exactly why we eventually need actual tools to measure things. But check out the specific comparison. It's brilliant, contrasting an air-filled balloon with a basketball. Both are round, both are relatively the same size, but man, they feel completely different. It forces the student to separate the visual concept of size from the physical reality of mass. Big does not always mean heavy.
The teacher's notes hit the nail on the head again here. The secret is focusing on the physical sensation of that downward pull before you ever introduce a scale. Gravity is pulling that heavier object down harder. Once a child truly internalizes that downward pull in their own tired arms, they are perfectly primed to understand a machine that does the exact same thing.
So how do we actually prove it accurately? That brings us to Section 5, Measuring with a Balance.
The chapter maps out a very specific logical progression here. First, you hold the items to feel the weight. Second, you make an educated guess. And third, you bring in the pan balance to verify the truth. It's intuition first, scientific verification second. And just like when we were estimating volume with those small bowls earlier, students start by using non-standard units to measure weight. They balance everyday items, a ping pong ball, a spoon, a pencil, against simple uniform objects like coins or unused erasers. It makes the whole concept of a unit of measurement totally accessible. An eraser is a unit. A coin is a unit.
Finally, for the grand finale, the textbook standardizes weight. It introduces the kilogram, the half kilogram, and the quarter kilogram. And I love how cleverly they do this. They use everyday pantry items as reference weights. A packet of salt, a packet of tea. If you want to know what a kilogram feels like, you don't need fancy lab equipment. Just go to your kitchen and pick up an unopened bag of salt. Boom! It completely demystifies the metric system.
I'm going to leave you with the chapter's final provocative riddle. Imagine you have 3 visually identical balls, one red, one orange, one green. How would you design an experiment to actually prove which one is the heaviest and which one is the lightest? Think about the pan balance we just talked about. Think about the process of elimination. It is an incredible test of logic that proves these foundational concepts have well and truly landed. Thank you so much for joining me on this explainer, and remember to keep exploring the math in your everyday world.